So let's take a look at this number question from the 2012 Junior Cert Higher Level Paper 1. So it's question 1A, and we're asked to give two reasons why minus 7.3 is not a natural number. So what's a natural number? Well, natural numbers are the ordinary counting numbers. They must be positive whole numbers. So we're talking about the numbers 1, 2, 3, 4, etc. all the way to infinity. Note that we don't count 0 as a natural number. So if we're looking for two reasons why minus 7.3 is not a natural number, well, first of all, it's not a positive number, it's a negative number and therefore not a natural number. And the second reason is it's not a whole number, it's a decimal and therefore not a natural number. So the B part of the question gives us a diagram representing the sets of natural numbers, integers, rational numbers and real numbers. And it asks us to place each of the following numbers on the diagram. So the first thing to run through is what each of those sets represents. So first of all, the set of natural numbers are the ordinary counting numbers. They're positive whole numbers. So starting at 1 and going all the way up 2, 3, 4, 5, 6, etc. So the integers then are all the positive and negative whole numbers and also include the number 0. The rational numbers are also called fractions, so any number that we can express as a fraction, a over b, where a and b are integers and b isn't equal to 0. Irrational numbers are numbers that can't be written as fractions, a over b, where a and b are integers, but they are real numbers, they exist and have meaning. So for example, a lot of surds are irrational numbers, the root of 2, the root of 3, the root of 5, and then special numbers like pi and e. So these are real numbers and involved in the real number system. We just cannot write them as fractions, a over b, where a and b are integers. One thing to note is that some of these sets are subsets of the other sets. So we can see in this circle here, the natural numbers are contained within the integers set. The integers and natural numbers are both sets within the rational numbers sets. And then the rational numbers, integers and natural numbers are all subsets of the real numbers. With that said, let's place these 7 numbers in the relevant position on our diagram. So first of all, minus 8. Well, minus 8 is a negative whole number, and so it's an integer, and so it goes in the Z circle. Pi is an irrational number that can't be written as a fraction, and so we have to have it in the R circle. It's a real number, but not inside the Q circle for the rational numbers. 1 over 3 is a rational number, can be expressed as a fraction a over b, so that goes in the Q circle. 6 is a natural number, so that goes in the inner circle. Root 2 is a number that cannot be written as a fraction a over b, so root 2 goes in the R circle. Minus 4.5 can be written as a fraction, so minus 45 over 10, and so it goes in the Q circle. 7 to the power minus 1 can be changed using a rule in our maths tables to 1 over 7, and so we can see that 7 to the power minus 1 is actually a rational number, and so goes in the Q circle. So all of the numbers have been placed in the respective positions in the diagram, but one thing to notice is that even though 6 is in the natural number circle, it's also in the integer circle, it's also in the rational numbers circle, and it's also in the real number circle. So 6 is an element of the natural numbers, the integers, the rational numbers, and the real numbers. A number like pi can only go in this region of the real number section as it's not a rational number or an integer or a natural number.